So we're continuing on our discussion of non-mutating algorithms. And now we're going to talk about non-mutating algorithms that will process and or compare elements in an iterator range. And as you can see here, there are three of these we're going to talk about: for each, equal, and mismatch. So I think we've talked about for each before. It goes and it applies a function to every element in a range. We've talked about equal, which checks to see whether the elements in a range are equal, possibly using a binary predicate or just comparing values. And then there's also something called mismatch, which checks two parallel ranges and returns the position of the first one that's unequal or that doesn't satisfy a binary predicate. So let's take a look at some examples here to make this all clear. First thing I'm going to do is I'm going to define a little functor, and this functor is a unary function, as you can see here. So it's going to have a single parameter to its operator function call method. Its constructor is going to stash away the output stream as a reference and stash away, or it's going to keep track of a count internally that starts at 0. Its function call operator will print the contents of the parameter passed to it to the output stream that was stashed away in the constructor. And the ++ operation is going to increment by 1. So we're going to keep track of the number of times this thing is called. We're going to define a little helper method that returns I, so we don't have to actually expose these things directly. And probably to be better about this, I should make this whole thing be a class and make this public and call this class. So now it's just a little bit more abstract, if you will. Okay, so let's come down here and take a look at how this works. This is very simple. We're going to go ahead and make ourselves an array of just values of whatever they are. We don't really care. They don't matter for the example. And then we're going to go ahead and call the for each algorithm at the beginning of the array, going to the end. And we're going to make an anonymous instance of type print, which is a functor, where we're going to go ahead and pass in cout. That's where we want the output to be written to. And you can see that what for each does is it's actually going to return the functor that's passed in, but after it's been potentially modified by the operator function call. And indeed, as you see here, it will be modified because it'll increment the count by 1 each time it's called. So when we're done, we'll get back a print object of type int, and then we can say func.count, and it'll tell us how many items were printed by returning what the value of I is. Let's take a quick look at for each. We've looked at this before. It's a super duper simple algorithm. It just goes through the range from beginning to end, calls the function on every element pointed to by the first iterator to the beginning of the range, and then it increments that first iterator by 1 so that it can call it again up until the point when it reaches the end of the range. And note, when we're all done, the function that's passed in by value here, and which has been used to invoke the operation each time, that functor will be returned back as the result. And you can see also how functors can trivially keep state, as we do here. So let's go ahead and run this example. And you can see that it prints out 1, 4, 2, 8, 5, 7, which is what we'd think if you look at what the function call operator does. And then it keeps track of the number of objects, the number of times that the range had something in it. And so it came back with 6, which is the number of objects in the range. Okay, so that's for each. For each is not quite as useful nowadays when we have something like the range-based for loop. You can do a range-based for loop to do pretty much the same kind of thing, it would be easy enough to refactor this code to use the range-based for loop in order to do the same sort of thing. In fact, it might be kind of fun to do this. Let's see if we can do a little bit of refactoring here just to illustrate what other ways of writing this code could potentially look like. So let's go ahead and declare ourselves an object P, which we're going to give cout to. And then we could say for auto I for A. So we're going to iterate through that array from beginning to end. And then we could say P, I think, will that work? Let's see if that'll work. That might work. So let's go ahead and see what happens there. If we get the same results, And indeed we do. So you can see that that's another way of writing this code, which is to essentially define an instance of our predicate, of our functor, as opposed to using the for each algorithm. So just another way of doing kind of the same thing. And then of course we could also drop down and use a lambda expression just for kicks. Let's go ahead and do that as well, just to show all possible combinations of these things for the purposes of posterity, perhaps. And down here, we're going to go ahead and say begin end. And then we just write a little generic function, auto I. And we're going to say, let's see, I guess we would say, well, in this particular case, we're not going to be able to get back the function. So let's just get rid of that guy. But instead, what we're going to do is we're going to have auto I equals 0. And then down here, let's call this guy J. Let's pass I in by reference. And then we can say C out J. And then we can say I++. And let's see if that'll do what we want. And indeed it did. The only little difference is I probably should have done this. So now it's got a little space after it. And you can see the results all come back the same. So what this example now illustrates is just different ways that we can mix and match for each, either using a functor, as we did with the version here, or we can have for each with our own little generic lambda function, which we do down here. And I guess I should put this as I, because that will have been updated. And then down here, just for kicks, we just write a little loop and do it kind of the old-fashioned way, using a range-based for loop, of course, which is newfangled. This example up here, also notice how I had to pass I passed the address of, which is just syntax for saying, pass this by reference, not by value. If we try to pass it by value, then of course we can't increment it. So we have to do this, and that says allow changes to the content of the local variable I that's passed as a parameter here using the capture clause for the generic lambda function. So again, lots of cool examples. Maybe it would be better to say, I don't know, total to avoid shadowing the variable and potentially confusing the output. So anyway, just wanted to show you a bunch of different ways of doing this, and which one do you prefer? So this approach up here with the print method, that's nicely self-contained, so it makes it easy to change stuff without having to do too much extra work. The downside, of course, is that you end up having to write this somewhat large and wonky functor, but it works. This approach down here is less large and wonky, but now we had to rewrite this code over and over again. So if I was going to reuse the print method, the print functor, it might be a good idea to define it like that and use this version. And then this version with the range-based for loop, in this case, it's probably not that useful to do it this way, but there are lots of situations where a range-based for loop is the way to go. So you can make your choice about which approach you like the best based on the examples I've shown you here.